Today we're going to learn how to collect like terms. The key definition we are first going to take a look at is like terms. So let's zoom out and take a look at its definition. Like terms are terms whose variables and their exponents are the same. However, the coefficients can be different. Let's go ahead and underline some key words. So, variables and their exponents are the same. However, the coefficients can be different. I'm going to give you several examples of like terms. Here we have 7x, x, and negative 2x. As you can see, each term has the same variable as well as the same exponent. That variable and exponent is x to the power of 1. However, when you have something to the power of 1, it is never written in. It is understood. Therefore, it would just be considered x. Furthermore, these terms all have different coefficients. We have no coefficient in the middle term. However, there is a 1 secretly hiding there that is not written in. So whenever you see a variable with no coefficient, there is a 1 secretly there, but it is not written in. It is understood to be there. Let's go ahead and summarize what we've just found out. These are all like terms because they have the same variables and the same exponents. Let's do another example. I'm just going to scroll up to make more space for myself. In this example, we're going to have 3 different terms. Our first term is 1 over 3 xy to the power of 2, negative 2xy to the power of 2, and 6xy to the power of 2. As you can see, each term has the same variables with the same exponents, and that happens to be xy to the power of 2. Let's go ahead and write that in on the side so we remember. Xy to the power of 2. Because these terms have the same variables with the same exponents, that makes all these terms like terms. Again, these like terms can have different coefficients. That is 1 over 3, that is negative 2, and that is positive 6. As long as they have the same variables with the same exponents, they are like terms. In this example, we're going to look at 3 new terms. We are going to look at negative 3xy, negative 3y, and positive 12y to the power of 2. Let's take a closer look at the variables and exponents for each of these terms. Here we have xy, here we have y, and here we have y to the power of 2. You'll notice that the variables and exponents for each of these 3 terms are completely different. They are not the same. Therefore, these 3 terms would be considered unlike terms. In our next example, I'm going to give you a little bit of a trick question. So these 3 terms are going to be 2x, 3x to the power of 2, and let's say 4x to the power of 3. The first thing you want to do is you want to look at the variables and their exponents. So over here we have x, this is x to the power of 2, and this is x to the power of 3. Let's move this up so we have a little bit more space to work with. These 3 terms have the same variable, so I'm going to write down same variable, and that variable happens to be x. However, they have different exponents, and that is a key point. Different exponents. For the first term, the exponent here, as discussed earlier, is 1. It's just not written in. The exponent over here is 2, and the exponent over here is 3. However, to be considered like terms, they have to have the same variable as well as the same exponents. But we've already established that they do have the same variable present, which is x. However, each of these terms have different exponents. Therefore, we have no other choice but to declare these terms unlike terms. I'm going to zoom out to show you all the work we did for these unlike terms. In our next example, we want to simplify this expression, negative 6k plus 7k. The first thing you want to do is you want to identify like terms. So we want to look for terms which have the same variables as well as the same exponents. Over here, we have k to the power of 1. Remember, the exponent 1 is not written in usually. And over here, we have k to the power of 1. Therefore, because these terms have the same variables with the same exponents, these would be both considered like terms. I like to indicate that with a symbol underneath. I'm going to use a squiggle. A lot of students have difficulty collecting like terms. When you have like terms, I want you to temporarily ignore the variable and or exponents and just look at the coefficients. The coefficient here is negative 6, and the coefficient here is positive 7. If I separate these coefficients out on the side, what I have is really negative 6 plus 7. Remember, I said we're going to temporarily ignore the variables and their exponents. At this point, this becomes an easy number line question. Let's go ahead and draw our number line. 0 is going to be somewhere over here, and negative 6 is over here. We start with negative 6 and we add 7 to it. And when you are adding, you're actually moving further to the right on your number line. If you were to count out 7 spaces to the right, you would end up somewhere over here. You would end up at positive 1. Okay? Therefore, your answer over here would be positive 1, and the variable stays the same, k. 1k would be your answer. However, in math, we usually do not like to write in or to leave the coefficient of 1 in front of a variable. Therefore, we can remove it, and our answer would just be k. And I'm going to put a box around my final answer. In this example, we want to simplify the expression negative 2x plus 11 plus 6x. The first thing we want to do is identify like terms. This term has a variable of x, an exponent of 1. This term is just 11, while this last term has a variable of x to the power of 1. If you recall, like terms have the same variables with the same exponents, which would make negative 2x and positive 6x like terms. Once we've identified like terms, we need to collect like terms. But before we do that, let's go ahead and rewrite this question such that the like terms are beside each other. So negative 2x is going to be beside positive 6x, and that positive 11 is going to tag along at the end. We're going to simplify negative 2x plus 6x. I'm going to do the work on the side, so let's zoom out and make some space for ourselves. As with our previous question, I'm going to temporarily ignore the variables that are within these terms. I'm just going to look at the coefficients of negative 2 and positive 6. So I'm going to put that on the side. Negative 2 plus 6. What you're going to use is a number line if you can't do this in your head. I'm going to draw a number line. I'm going to put 0 somewhere over here. We start with -2. We are adding 6 to this -2. When you add, you're moving further to the right on the number line. If you count out 6 spaces, you're going to end up somewhere over here, and that is +4. Therefore, -2 plus 6 is +4. Let's go ahead and write that over on the left. +4. The variable stays exactly the same, so it remains x. The +11, because we didn't do anything to it, it stays the same. Because 4x and +11 are unlike terms, that means we cannot further simplify this expression, and 4x plus 11 is our final answer. In our last example, we are going to simplify the expression n minus 10 plus 9n minus 3. The first thing you want to do is identify like terms. Altogether, we have 4 terms. This term has a variable of n to the exponent 1. This does not have any variables. This term has the variable n to the exponent 1. This term doesn't have any variables as well. If you recall, like terms have to have the same variable with the same exponents, which makes n and +9n like terms, which leaves us -10 and -3, and these would be considered like terms with one another. In our second step, we are going to move like terms beside each other. So n and +9n go beside each other, the -10 and the -3 go beside each other. Let's first simplify n plus 9n. Before we proceed, I want you to take notice of this term of n. There is no coefficient in front of this variable, but like I've said numerous times, there is one secretly hiding in front, and I'm just going to write that in to make life a little bit easier. So I'm going to write that 1 in front. We're going to do some rough work over on the side. As I've said before, you kind of want to temporarily ignore the variables for these two terms. So just look at the coefficients. The coefficients being +1 and +9. This is pretty simple. +1 plus 9. We don't even need to do a number line for this, or we shouldn't have to, and that is 10. Let's go back to the left and let's simplify this. So we have +10. The variable stays exactly the same, so it remains n. At this point, let us go ahead and do the last two terms. So -10 minus 3. I'm going to do the work on the side. -10 minus 3. Some of you may be able to do this in your head. If not, go ahead and use a number line. I'm going to have 0 somewhere over here. -10, let's put -10 over here. We are going to subtract 3 from -10, which means we're going further to the left on the number line. If you count out 3 spaces to the left, you'll end up at -13. So -13 would be our answer. We're going to take that -13 and we're going to put it over here to the left. Therefore, because 10n and -13 are unlike terms, that means we cannot further simplify this expression, and 10n minus 13 is our final answer.